Okay, again, another video where I'm just trying to show you how to use a procedure. I'm not telling you why. Unfortunately, I'd love to elaborate on why this is and where this comes from. Essentially, it comes from the Pythagorean Theorem, but I just want to show you how this works, okay? So let's say you're trying to use a map and go from point A to point B, okay? And you need to figure out what that distance is right there. Well, if this were on a coordinate plane, that'd be really nice because the coordinate plane, I could plug it into a nice formula. Unfortunately, things aren't always in coordinate plane form. However, more application, maybe in the GPS using latitude, longitudes, which is somewhat like a grid system, this is how a GPS would function. You could plug that formula or program it into the GPS or program it into your program that would then calculate distances for you. But like I said, this is an elaborate conversation, so here's where we're going. Point A, this coordinate, and point B, this coordinate. Now I want to know what that distance is, that straight shot distance. So we're going to use the distance formula. Now notice here it has x2 minus x1, y2 minus y1. That means all my coordinates are x, y, x, y. It doesn't really matter which one is the first point, which one is the second point, as long as you're consistent. So pick one. Say, all right, A, you know, that comes first in the alphabet, so you're my first point. B, you're my second in the alphabet, you're my second point. That's all right, just go with it. Here's one point, here's another point. So let's plug this into this equation. You're just using substitution, all right? Substitution, substitute it into the equation. So x2, what, that's 4, and x1, that's 1. So I just substituted that there like that, so x1, x2, and we're adding, and the rest of it just stays the same. Notice, I haven't changed anything else, I've just changed what the x's and the y's are. Now y2 is negative 1, notice, negative 1, and y2 is just 2, but I'm using subtraction, so that's why that appears to be on the negative side. Now, use your PEMDAS, or however it is, your order of operations, as some people call it, or as it's supposed to be called. PEMDAS. Alright. Parentheses first. Alright. Square root. Nothing else changes. Just focus on those parentheses. 4 minus 1 is 3, and that square stays there. You could keep the parentheses, that's fine. Negative 1 minus 2, well, that's negative 3. I just put the parentheses to separate those signs right there. Alright, so that's squared. Then, exponents. Exponents is next, so let's take care of those exponents. Well, 3 squared is 9. Negative 3 squared is also 9. Well, that's convenient. Now let's take care of that addition, okay? Addition, the square root of 18. And again, if you want to leave it as the square root of 18, save yourself a little trouble. In my class, that's fine. No worries. I won't argue about that. But if you plug it in the calculator, you get a nice decimal that kind of goes on forever, and you can figure that one out. Now, some of you are like, oh, Mr. Moreno, I don't like this. This is such a, you have to memorize this formula? It's like, no, you don't necessarily have to memorize this formula, because look at this. This is on a grid. So I can actually use my slopes to kind of go down and over, kind of like slope rise over run kind of thing. And it forms a right triangle, just like we use with the Pythagorean Theorem. So I can say, all right, this distance, what is this? 1, 2, 3. This is 3 long, and it goes 1, 2, 3 across. So this is has a triangle with 3 by 3 on its sides. So I could use the Pythagorean Theorem. Alright, this is my hypotenuse because it's directly across from that right angle. So I just consider that x, so I know that my hypotenuse is x, and the other two sides are 3, so that's lovely. Simplify with your exponents, 9 plus 9, because 3 squared is 9. Alright, and then add it together, it's on the same side, so that's 18, excuse me, that's x squared. You don't want x to be squared, you want it to be by itself, so we're going to square root both sides, and guess what? I just found the exact same answer as I did using the distance formula. You could do that anytime you'd like, interchange them, unless of course somebody wants you to memorize this, which would be quite a pity, because you could do it in a lot of different ways. So, good luck, I hope that helps you, I'll talk to you later.